Okay, and we're live. Um, 8 days ago, I posted on Reddit that I was going to start making a card game, a multi-platform, single-player deck building game, with the low-end cap being for mobile devices. And I stream every day, but a lot of people asked for something uploaded to YouTube, something more shorter and compact. So this video right here is just to go over basically whatever I did the past week. I'll be making a video like this every week. Usually it'll be uploaded on Monday will be the goal, but usually programming will take its priorities. This is something more of just try to help keep people caught up if they want to like learn along while we make this game. This is going to be a game that's going to be fully released. It's not going to be. This isn't really like a fun project. This is actually going to be something that I'm going to be releasing through Android Play and the App Store and on PC and stuff like that. So right now we're 8 days in. So everything that you see is stuff that's was started after or within that period of time. We're going to go ahead and play the game to show you where we're currently at. So right now we have the game board. The game board consists of 9 rails. These are these little these long objects that you see right here that I'm hovering over with the cursor. These rails are the stats. And basically the goal of the game is that you want to get one of these up to 100, which will be over kind of right about here on this rail, and you want to prevent it from going down to 0 or below. Some of these look like they're kind of near 0, but they're actually about 5, and they're just not active right now. Currently, we're only utilizing some of the stats, and the stats work differently. Ultimately, at the end of the game, each stat's going to be corresponding with its own unique style of play, much similar to like Magic the Gathering's color system, where blue is more about control and casting spells, but green is more about putting creatures on the board. We're going to have similar things like that, except we're going to have 9 stats, and they're going to work a little bit differently. We have our deck, which is right here in the center. It's like a little elevator shaft. Cards get raised up, and it tries to keep at least 20 cards above the 0 axis so they can be available. 0 is the axis. We have a debuff hand, and we have a buff hand. We also have, our debuff pile and our buff pile. And we also have our current hand. We have our discard pile, which is right here, and we have a button to go to the next turn, and we have a turn counter. Tells us what turn we're on. Currently, we're on turn 1. So we're going to go ahead and we're just going to draw a card. You can see the card comes up, and we drew Thunderlord's Decree. There's only 6 cards in this deck so far. They're randomized, so I don't know what we're going to get. It's going to be different each time we play. Our hand isn't randomized. We start with 3 Pathfinders. Thunderlord's Decree lets us cost for 2. It consumes 2 of stat 1, which is a stat 1, and it adds 7 to order. This right here is stat 3 is our order. So this right here is order. So we can go ahead and cast this card. We will see this decrease by a tiny bit, and this will increase by some. So we'll go ahead and cast it. And you can see this moved up a little bit. A reference point is these over here, because these all started out the same. We're then going to go ahead and end our turn. We then see the turn indicator changes. We go ahead and draw a card, and we get Unseen Greed. Unseen Greed lets us draw 2 cards per turn, or an extra card per turn to be, it's very important that we actually specify that. So we go ahead, we're going to cast Unseen Greed right now. Now, buffs don't take effect on this turn. However, debuffs do take effect of this turn. Buffs only happen or applied at the beginning of your turn, so they have to be existed since the start of the turn. Very similar to like Exhaustion or Summoner Sickness with other games. So basically, even though it's a good card, we can't really have anything help us this turn, but it'll help us next turn and all the turns after that. While our debuff pile, they will affect immediately. So if we drew something bad, we will have that applied before the end of the turn. So you see we can draw an extra card. Right now we just have some debug output saying, hey, no draws left. That's perfectly fine. We go ahead and end the turn. We are now on turn 3, and we will draw a card. Another Thunderlord's Decree. Well, why not? Let's go ahead and cast it. Oh, we get our extra draw. Actually, if you watch this, if we try to end the turn, it says, hey, idiot, you forgot to draw, because we have an extra draw left. So we're going to go ahead and draw that card. Ooh, Miasma. Miasma is our first debuff card we got here. It's going to go to our debuff pile, and at the end of all of our turns, we're going to lose stat 7. And that's stat 7 right here, by the way. Wait. Yes, that is stat 7. We will go ahead and end the turn, and you saw stat 7 just went down just a little bit. Go ahead and draw this here. Pathfinder. We'll discuss Pathfinder later. We first want to get, another Miasma. We first want to find a different card. Something that isn't Miasma. There we go. This is a binary card. This is a card that lets you choose two different decisions. This one, it lets you consume two cards from your discard pile, lets you gain 10 of stat 1, or you could choose to lose 10 of stat 6. Well, why would you ever want to lose 10 of a stat rather than gain 10 of a stat, when the whole point of it is that you're supposed to gain stats, not lose stats? Well, the thing about it is if you don't have two cards to discard, you can't cast this. You're forced to select this one. So this is just one of those cards kind of showing a little bit of how the card structure is going to be, how some cards can have good benefits and bad benefits based off the situation that you in. I think RNG is a very critical part of card games, so we're going to have a lot of RNG. Lots of ways to screw you over. A lot of things that will have you yelling at your computer or your mobile device. So we actually have two cards in our discard pile, so we're going to go ahead and consume those two cards. And you see that this actually went to our discard pile too, so it stays in our discard pile. And if we ever want to see what's in our discard pile, we can just go ahead and click on it and it'll come up to the screen. And same thing with our buff pile and our debuff pile. And if we have multiple cards, we can actually like scroll in between them and they expand and collapse out. These animations, they're very dynamic, and we're going to go over that once we're actually looking inside the blueprint structure. We're going to go ahead and get another miasma. We may be losing the game for miasma. Another Thunderlord's Decree. All right, but anyways, you saw that binary card. Well, that's actually a type of object in our program. So Pathfinder says move target dual choice card from the deck into your hand. And so those binary cards, they're dual choice cards. That's the in-game like text name for them. I'm going to go ahead and cast Pathfinder. It's then going to display every single Hungry Maws, which is the only binary card in the deck. It will then let me go ahead and scroll through them, select, unselect, and I can choose one. Which one will be the lucky one? Let's get the one near the right end. Right now, it doesn't shuffle after it gets put back into our hand, and so we know the one on the right is the one that's closest to the top of the deck. Ooh. Kind of cheating here, using a little bit of an exploit, but that's fine. But this shows the importance of why you need to have good logic when you're doing this, because if we don't shuffle our deck after this, then we can just keep pulling out the most recent one. Or maybe we might even want to have it so it does that. Ooh, it'd be a good mechanic. I'm going to go ahead and end the turn, losing a little bit more stat 7 because of miasma. We're going to lose a little bit more next turn. Unseen Greed. Hey, let's get an extra draw because we are running out of time. So we need to win. We're going to go ahead and we're going to consume 2. Let's see if we can get this up. Oh, right now all the input is set for mobile. So even though I'm using a cursor here, it's still passing over the mobile input. So if I want to cast a card, I swipe up. If I want to like cancel anything, I swipe down. Another miasma. In viewing cards like this is all just sliding back and forth. This is just touching left and right. Go ahead and draw a card, Pathfinder. And we just lost the game. And the game will just reset. So right now, not much of a game, but we do have a lot of the backbone done. And we're going to go ahead and go into the programming. Now, all the programming is in blueprints. Now, if you're not familiar with Unreal Engine and what a blueprint is, it's basically a way to code graphically without typing any programming syntax whatsoever. It's all visual. The reason why I'm doing this, though, isn't really much by choice. I'm using a Windows operating system. That's really the only system available to me to program on. And if you want to program something that's going to be compilable for iOS, it needs to be on a Macintosh if you want to use C++ and Unreal. So it's kind of a limitation to not only Apple, but to Unreal, and so I'm using blueprints. However, the usage of blueprints really hasn't limited me so far. There's only been about 2 instances that they've kind of caused trouble, and I was able to overcome them. And we're going to go ahead and give an example of a blueprint. So we're going to go open up our player object. Right now in our game world, our player is just a camera with some reference points and our decline and approve buttons that are up at the top. They start hidden up from the screen and they kind of get lowered. Oh, one thing also note, well actually before we do that, we'll go to our game world. I want to point out that this game, there's no 2D assets. Everything is 3D in this game. Everything. Our deck is all physically there. When we're moving objects, we're physically moving them in the game world. When we click this button and it goes down, it's physically moving down. So this is a 3-dimensional card. It is moving across 3-dimensional space to get to our hand. Same thing when we move this card. It's moving and rotating on 3-dimensional space. There is no 2D assets. Even these the words that you see here, they're not 2D. They're actually 3D renders. They're flat 3D renders, so they're essentially 2D, but they are three-dimensional. They actually can cast shadows, they can hover, and I can interact with them. But here's our player object. So because everything's 3D, we need these points. We have a point for our the point where cards get displayed near our face. So we have that point there. And that's important because if we have multiple cards that we want to display and we want to space them out, all we have to do is keep track of an offset of where they're going to be across the x-axis. So we spawn our center card right here. We spawn another one to the left. We spawn one to the right. And we just need to get the count of cards that are going to be displayed and then just set the offset to their index. And then because they are bound to this point right here, all we have to do is move this point and they will slide along with it. So that's how our touch code is working when we're sliding between cards, when we're displaying them. We have a point that's going to show where the cancel and the approve buttons fall down. So this approve button, it's going to move down to here. This cancel button, it will move down to here. And we also have a point for our hand, which is right here. And that's the cards that are displayable in our hand. So right in front of the camera, you can see those. The game board gets spawned off of a player. It's spawned through the coding. So the way that this game works is that when we look at our game world, we have nothing but the player. The world is just an empty, dark void except for the player. There's not even any lighting. But when we start the game, we have some logic within our player. And we'll go ahead and this will be our first look at blueprints. We're going to go to our... here we go. Our event graph. And this is a blueprint. This is the equivalent of programming in Unreal for using blueprint system. It's graphical, but it follows all the same rules as programming for the most part. White pins are execution pins, and those follow the order of logic that's going to be happen. So this event begin play is the very first thing that happens. Once this object is loaded, it immediately begins performing this logic. It then goes through the sequencer that says we're going to do this task first, this task second, and this task third. The first task is just going ahead and saying we're enabling input and we're spawning our game board. So that's where our game board is spawned. That's the object that contains the rails, it contains the deck, and it contains the next button, the turn timer, stuff like that. They're all there. And then the deck itself is an object that gets spawned from the game board, and the hand gets spawned by your deck. So by just creating one player and placing it anywhere in the world, you can rotate it any which direction, you immediately spawn a game board that's correctly associated and correctly positioned with it, a deck that's correctly positioned associated with it, and a hand that's correctly positioned associated with it. So there's like a daisy chain of relationships here. But a game board gets spawned. This is just setting our default values, which is part of our game board. So we're actually saying, hey, our game board that we just spawned, let's store it into a reference, and then let's go to that reference, and let's go ahead and set some stat values. And these are custom functions that I made inside of it. This also initializes our approve and cancel buttons. They're actually child actors, which an actor in Unreal is just an object. It's just another object. So we actually add some child. They're not inherited from the player object. They are child actors. They're related to it. So they're tied dimensionally, like through X, Y, Z transformations, their location, their rotation, and their scale. They're tied to it. That's basically what a child means. And the reason why I add them as child is because that means I can move them around in this viewport and I can see exactly what they look like before we're in the game. So there's some pros and cons. The pros is that you do get to see them in the viewport. You can move them around before you run the game. The downside is that Unreal, for some reason, or maybe if someone out there knows of a better way to do this, I have to cast everything every time I want to utilize it. Unreal doesn't do a good job at retaining their object types of child actors or child components that are actors, child actors that are child components. They're both. And so we have to cast everything, and it gets a little bit annoying to do so. But it's not a deal breaker. Next, we have some input handling. Basically, for our player object, all we have to worry about is swiping. All our direct tapping and stuff is actually tied to our card logic. But if we're doing swiping, we could be swiping for many different ways that aren't directly to a card. We then have our hide and single display, and basically what this is that we're just slowly transitioning to have that a card from our hand or a card from our deck. Anything we're bringing up a card, it comes to our close-up point. When we draw a card, this is also called, and it comes up to our screen. And we're just linearly interpolating. And what linearly interpolating means is that we're moving from one point in the three-dimensional world to another point in the three-dimensional world over a smooth time frame. And that's what a timeline is. And this is one thing that's a bit unique to Unreal. It's pretty handy. It's basically a way to initialize an event tick tracker over a period of time and have a value be associated with it. So in this case right here, I'm basically saying, I want to track for 0.6 seconds anytime this part of the logic's called, that it then, at the beginning of that 0.6, it has a value that starts at 0, and then it has a value that then ends at 0.6 by the time it ends, or that it's over. I'm sorry, this is actually 0.1. I'm sorry, 1. It's just a value of 1. So between 0, at 0, it's 0. At 0.6 seconds, it's 1. So it's just a way to scale between 0 and 1 very smoothly. And when we go to our event graph, we use a linear interpolator, and we're saying, hey, this is a position that we want to come from, and this is a position that we want to go to. Move across that based off of this value here, this 0 to 1 value. And that 0 to 1 value is powered by our timeline. So the timeline does a lot of cool things, and it lets us help us evenly smooth across transitions. I'll probably be using these a lot for any sort of transition that I want to have a static, not a static rate, but a static amount of time. So I may not always be moving the card from the deck. I may be moving from the discard pile up to the screen, or maybe moving it from my hand to the screen, or maybe moving it from my debuff pile to the screen. And since those are all different locations, sorry, banged the mic there. Since those are all different locations, that means that the time it takes would be different if I had the same rate. It would be, you would have uneven time frames of depending on where they're coming from. So I want to have not a static rate, I want to have a static time frame, and that's what timelines are really, really good for. Show multi-display. This is the part of the logic that goes ahead and shows multiple cards. So when the cards get like fanned out, like if I'm viewing multiple discard pile or debuff pile or buff pile, and the cards fan out, that's what this logic does. Now this is easy because all we have to say is like, we want to get it from wherever that card currently is and take it where it needs to be. And we don't really care where it is. All we need to know is its location. However, when we unload it, when we're saying, hey, we want to retake the cards that are in our multi-display and physically send them back to the locations that they currently belong in, well, we need to do a little bit more logic here, and this gets a bit extensive. But what this means is that no matter where our card came from, we can send it back to exactly where it came from. We don't have to be worried about if we're grabbing cards from both our deck. Like imagine if you had a card that said, list every card that is in play that is of type X. So that could be a lot of cards, but those cards could be potentially in the debuff pile, the buff pile, your hand, or the discard pile. They could potentially be in all of those. So we need to be able to grab all those cards from all those different locations, and then we need to say, put them back in those exact same locations, because we're only viewing them, or we're making a selection choice off of them. And so that is that logic there. And we're going to go ahead and we're going to go back to our game, just in case if we forgot. And we're kind of go through that. So our Pathfinder, it lets us select a binary card. So we're going to go ahead. So this is our multi-display. This is our logic that lets us scroll back and forth. And if we click cancel, it's going to send everything back to the pile that they come from. However, our card, you can see it down here, saying it's moving from deck, so that's all going to go right back into the deck. This right here is our single card close-up, so this is the first one that we're seeing. Right now, it only has a transition animation for when we're bringing it up. When we go down, it immediately goes back to our hand. So that's something to do in the future. We're now going to go back into our player object. This is logic for our subselection. Basically, our card object has a number of cards that are needed for its subselection. So when we cast Pathfinder and it says select a card, we actually have a variable in the card type Pathfinder that says, hey, we need at least one card to be able to complete our selection. And what's good about creating these base types first means that I can easily create more cards of the same type very, very quickly. So I can create another binary card within under 5 minutes. I could create another standard card in under 5 minutes. I could create another sub-selection card in under 5 minutes and things like that. And these are separate types. Pathfinder is a type of sub-selection. It is a card that when I play it, I need to make a choice that is dependent on multiple cards from either zone. So if it's something like discard 2 cards from your hand, or remove 2 cards from your discard pile that you can choose, or target debuff gets destroyed, stuff like that. So that's why we have a base logic for all that card. So all we have to do is just create a new child type of it and inherit it from the parent of sub-selection type card, and we can easily move in and out of those. Unseen Green is called a standard card, or I'm sorry, this is a buff card. And so that means when we play it, it doesn't get casted, it doesn't go to our discard pile, it goes to our buff pile. And then every time at the beginning of our turn, we iterate through all cards within our buff pile and we apply their effect. So in this case, we gain an extra draw per turn. Another Unseen Greed. Unplayable. The reason unplayable is in this hand right here is so we can view the cost of the card. There is cost for stats, and then there's also a type of cost. So the one that's pointing up means that we need to have a threshold. That means we need to be above 80. And so that's stat 1, stat 2, and stat 3, and stat 4 that we're showing right here. So we need a stat 1 that's higher than 80. We need a stat 90 that is equal to 80. That's what the right triangle means. And a downward angle means we actually need to be below it. So this is going to be the reason for having like something that says you need a stat below is that you might be building a deck that's going to be built around boosting one stat, and you can sacrifice another stat, and if you get that stat low enough, you can play some cards that give bigger benefits. So we're putting risk and reward in there. But right now, these are going to be improved upon. They're very temporary costs, but these are dynamically added as well to our cards. So we just need to pump in some values. It's actually an array of a struct, so we just add a row into that array, and we just type in the value of how much it costs, what the type is, and that's it. And it automatically generates, oh, and what stat it's coming from. It automatically generates there. In the future, we're also going to be color coding the stats. So one thing that I'll probably be doing this week. We're going to go until we get to a debuff card, which is Miasma. Thunderlord's Decree is also a standard card. It's like unplayable, except we can actually play it. And see, Unseen Greed means that we have to have below, this is actually stat 3. We need to have below 40 stat 3, so if we cast it, it'll say we can cast it because we're below it. If we had more than 40, it would actually get back an error and saying, hey, you can't cast that. And that actually is true. If we go to unplayable and we try to cast it, you'll see up here it says cost check failed, because unplayable is called unplayable because it has unrealistic stats to cast. I guess we should try to stay on topic though. That pretty much covers the main programming that's in our player object. Here's just our event tick. This is something that something has a standard rate. So it's not something necessarily that moves at a static time frame. It moves over the course over a static rate, and that's when I use that here. All these things on the left-hand side are functions. And we're going to go ahead and just go through these functions. One is a function to select cards, and basically this toggles whether which card is being selected. So if I'm selecting one card and I tap another card, we need to know that we're unselecting one card and then we're selecting a new card. So that's all this logic does right here. Update multiple display position. Multi-display is what I call it when the cards fan out. That's what I'm currently just using as a term for it. And basically when we touch it and we're moving left and right, we need to be able to update it. So what we're saying is anytime we're touching the screen and we're moving, we're going ahead and calling this logic every single update to make sure that we're staying in the correct position. Navigate display cards. This is actually something that's kind of deprecated. We're not really using it right now, but this is for swipe functionality. It's actually still in the game. It's just not really useful for anything. Well, it's useful for one thing. If you have a multi-display that says like it's 100 cards and you want to quickly get to the left-hand side or the right-hand side, you can swipe and it'll automatically take you to the edge of one side or the other. Add array to multiple display. Basically, the cards that we have in our multi-display, the display that fans out, is just an array. So this is how we load it. We make sure that we do the correct changes to it. We make sure that we change the state machines for the cards and make sure everything is set up appropriately. Stat require met. This right here is basically just a check. We're just passing our stat required and returning a Boolean. We're saying, hey player, do you have enough stats to do something? If so, return true. Update draw count. This is basically just a function. It's here just for future proofing because I'm pretty sure we're going to need to do other stuff. But this says anytime we draw a card, we call this function, and we're just subtracting 1 from our draws remaining. Calc draws remaining. We're just basically saying we're just pulling the value. More future proofing. On swipe, this is our logic for swiping. I kind of have it broken up to directions: up, right, down, and left. So those are how they're split up. Swiping is just whenever we touch the screen, and when we let go, we've moved across X amount of units. Right now, I think it's set to 500, so it's a pretty significant amount of value. I do need to change it though. One thing that I want to adjust is I want to make swiping to the left and right be less restrictive than swiping up and down, because we have a lot more real estate left and right on a screen than up and down. Begin subselect. Basically, anytime that we want to have a choice where we select cards, I've already future-proofed this to be able to look for types of cards and zone restrictions. So Pathfinder, it pulls a binary choice card or a dual choice card from the deck. So we can immediately say, hey, what zones are we going to allow in our sub-selection? I'm saying, in Pathfinder, it's saying, hey, deck. We're only going to be looking at deck. So only this logic gets ran. We then add all the cards in our deck to an interim array, a middleman array, an array that's just going to be there just for the time being. Once we have that done, we then go and we check for applicable types. A little bit of a typo there on the types. But then we go through and we just make sure, like, hey, is it a binary card? If so, add it to our multi-display array. So that's actually the function that we were just looking at a bit ago. So we basically do that check. And then once we have all the cards in our array that we need to, we then go ahead and just do some cleanup logic. And then we go ahead and we show our array. That's our show multiple display array function. And this right here is just go ahead and just adding it. You'll see a lot of these nodes, change state. Change state is a function within our card object. And basically, we use state machines for our card, we use a state machine for our player, and we use a state machine for our churn. A state machine is basically, it's a way to track when input would be appropriate. The key to using a state machine is make sure that you define states that can never overlap. Like, we never want a state of a card that could be both in our deck and in our hand, if it is possibly both in our deck and our hand. However, with this game, we know that it's not possible to have a card that's both in the deck and in the hand at the same time, so those are actually good states. A bad state would be saying something that is multi-display. Multi-display may not be the best state. In this case here, I have it working for some other reasons I'll get to later, but basically multi-display may not necessarily be quite the best state. The reason why is because you may be in multi-display and you may also be in the deck at the same time. Like if we're multi-displaying a card from the deck, it could be in both those states at the same time. So that might be a time where it's a bad choice. And now that I think about it, it might be good to have a secondary state machine for the cards just for visual layouts to say where they're currently at. But right now, how I'm actually getting past that is in our state, I'm also tracking a previous state. So anytime we change the state, we look at the previous state. And so that kind of gives me the same functionality as having a state for where it is, as long as my visual transitions don't happen more than 2 steps apart. which could happen, but if so, I'll do the thing where I create a sub state machine just for where the cards are visually. And that takes care of our player object. We have just a small list of variables here. The key ones are the arrays. There's the cards to display. That's the ones that are showing up in the multi-display. And the subselect cards. The subselect cards are the number of cards that we actually currently have selected. So right now, if we use Pathfinder and we click a Hungry Maws from our deck, this gets added to it as we have it selected. If we unselect it, it gets removed from this array. And so if we were checking to see if we selected the right amount of cards, all we have to do is look at how many cards are needed from our card reference that's making the cast. And then we say, well, how many cards are in our subselect array? If it equals, then we know we have the right amount of cards. Okay, so that's our player object. That's our main meat and potatoes. That's where a lot of our logic's coming in. But remember, our player spawns a game board. So we're going to go ahead and look at the game board. Visually, the game board looks a lot like the game when you're looking down. You see that the deck is not quite here. It's invisible. Well, it's just not. It's being loaded into the object after the game has been ran. Just like in the player object, we have some arrows. They're kind of hard to see. There's one that's clipping in through the ground. Here's another arrow over here. Oh, nope, right there. And we have another arrow over here. And these are just reference points within our three-dimensional space, and they help us linearly interpolate between locations. So when we say, hey, we want to send a card to the debuff pile, not only do we change its state to the debuff pile, but we also say, move to where this arrow is in the game world. And these are really helpful because you don't have to do any you can do a lot of cheat math by just saying, hey, linearly interpolate to this point. Because if I rotated this entire object, like if I get a default scene root and say if I was to move it around within the game, all these arrows would stay in the exact same reference to this object. So they're very, very useful. All the rails are child objects, and that's why you see like these little white sprites circles that are in the middle that are kind of clipping through them. Those are each child objects. And that's also why you see one over here, because our counter is also just an object. Let's actually increase our speed here so we move a little bit faster. We're going to take a little peek inside of our counter. You'll actually see that the counter is a physical wheel. Like everything is 3D. There's no two-dimensional objects. So these are decagons. Each decagon has a number associated with it, 0 through 9, and it physically rotates. So that's how it tells our turn. It actually is rotating. We'll actually go into the blueprint now. We're going to try to speed this up. We're going to try to get done in under 45 minutes at the very least. Here we have a question. Sorry, but my speakers aren't working on my PC at the moment, but could you tell me how to change the setting on my blueprint so it's not reading read only, please? Unfortunately, dat_nerd82. I don't think I know how to set it to read only. So you have a blueprint and you're not able to change anything inside of it. I can't say I've ever encountered that. I didn't know you could set a blueprint to read only, but it makes sense why it's there. I would recommend go ahead and checking out the Unreal forums, but unfortunately I don't have an answer for you. But hey, you're going to be in the recording. How cool is that? We're then going to go ahead and take a look. Actually, nope, we're going to stick with the game board. We're going to look at our functions real quick. Send card to zone. So if we're moving one card from one zone to another zone, it's all handled by our game board logic. So right now we can send a card to our deck, which doesn't really do anything because we don't have any. I haven't thought of a card yet where we'd want to send it to our deck yet, so I haven't thought of the logic we're going to do for it. So our deck isn't really doing anything. But we can send to our hand, we can send to our discard pile, we can send to our buff pile, we can send to our discard pile or debuff pile. And all of these, they basically format where they should be within the world location and handles all the stat changes that are needed for them. So it's all about future proofing. We can use this anytime we want to send anywhere from any of our other actors. And also because all our actors are being spawned, they're being daisy chained. That means that we can cast any function from, or I wouldn't say cast, I'm mixing up card logic with programming logic, because casting is also programming logic or programming term. If we ever want to access a function from one object within that same chain, we can easily do so. Through our references that we're passing over through each other. When we're spawning a game board, we're setting a reference to which player owns that game board, which deck belongs to that game board, and things like that. Very, very important to do that. This also means that if we wanted to create a multiplayer game, like if we wanted to spawn like 50, if we wanted to spawn 50 game boards all at the same time, we could do so in our game world, and they would have all the correct references to work with each other, but they wouldn't clash, and like you wouldn't have a player that's accidentally sending his card to another person's debuff pile if that was the case. We'll go ahead and get into format zone. Format zone is pretty much like send to zone, but basically it says, hey, make sure that everything that's in the current zone, discard, debuff, hand, deck, things like that, make sure that they are physically in the game world where they're supposed to be. And we call this at a lot of times, like if we pull a card out and we send it back in, we might call a format just to make sure that everything looks nice and neat there. Modify stat. This looks like a lot, and it looks pretty, but it's not much of anything. Basically, what we're saying is we're moving our rails, because each rail is a child actor. So we're saying, hey, each of these child actors, which stat are we adjusting? Once we adjust that stat and we record that stat, go ahead and move that rail location. And so you'll see these little dials. They just move whenever the values are changing. So that tells us how our stats are. The actual value, the variable that's actually storing the point value is actually their location. Because I have their location, the relative location, I can easily go ahead and find out the value. And I made it very simple on myself. I made their start point 0, 0 on the actor of rail. So if we go to our rail, this is our mesh for it. And our 0, 0 is right about here. So it's actually where 0 value is in the game world. So when a stat is 0, its location is 0. When its stat is 100, it is always relatively y 100 backwards, actually. It's negative 100. It's negative 100. It's not positive 100, but it's 100. So if the relative location of that dial is 66, then we know the stat value is 66. So that was both a collaboration between designing the mesh and also designing the programming with it. I made sure that the mesh and the actor origins were all at 0, 0 when I wanted the value to be 0, and I made sure that the width that it needs to travel is exactly 100 units. A unit is centimeters in Unreal, by the way. So actually all this stuff in real world, fairly tiny, because 1 unit is centimeter. A card is 2 units tall, so each card is 2 centimeters tall, which is actually rather large for a card. We'll go back into our game board. We'll now look at our get stat. It's similar to what we just saw. Instead of setting, we're getting. Nef cards and discard pile. This is what we use to for our logic to for Hungry Maws, which requires to discard 2 cards from our discard pile. I'll probably update this in the future to say NF cards in zone, and I pass it a parameter for which zone I want to do. An example, like the format zone and the send to zone functions, they accept a zone that I want to check for. So I probably will do this and expand that in the future. Consume discard card. This is also kind of a similar thing that we need to expand upon, but right now it's just saying, hey, a card that's from our discard pile that is going to be thrown away forever, it will never be able to be accessed from the game in any other reason, it's completely destroyed, it goes through this logic, and it literally gets destroyed. Like from the programming term, we're destroying it. It's getting removed from memory. So there's nothing that we could ever do to get it back. It's, I would say it's like old Exile in Magic the Gathering before they realized Exile was not really much of an exile. It's more of it is like a timeout. I don't know why, but Exile is now timeout, pretty much, in Magic the Gathering. We then have move to next phase. Basically, this is what we're saying, what is the current phase, and what phase do we need to move to based off the current phase. So this is part of our phase state machine, and this is just like a handler for it. It doesn't really do too much on its own. Then we go to set hand locked. Basically, I use this logic to be able to lock input from my hand. If like an animation is playing, we want to make sure we're not accidentally clicking cards in our hand when the animation is playing. Or if we can't, if it's not time to draw, like if it's doing the upkeep phase or if it's doing the debuff phase, that we're not accidentally playing cards during it. So this is just how we just go ahead and lock that down from input. We'll go to our event graph real quick and just take a look at our phases. So basically, our phases are pretty basic right now. We have the setup phase, which spawns what needs to be spawned into the game world. So every time the game resets, we go through this logic as well. Our upkeep logic is basically to go through, update our churn counter, and go ahead and set our number of churns that were needed. Buff phase, we go ahead and we run through all our buff cards. In this case, we have Unseen Grid as our only buff card. We then have our draw main phase. In this game, you can draw and you can play cards in any order. You're not forced to draw a card. If you can draw 5 cards, you could draw 1 card, play a card, draw another card, play a card. But you are required to draw as many cards as you have to. So if you have 5 draws, you do have to draw 5 times, but you can draw to any order of when you're casting. It's not like Magic the Gathering where you have to draw and then cast. Debuff is like buff, it just happens at the end of the turn. We go through every card in our debuff array and apply its buff effects. Cleanups is for any sort of cleanup logic that we need. One example of cleanup logic is that we then reset our cards to draw. Because imagine if we had Unseen Hand in our buff pile and we just added that value and we never subtracted it. If we ever removed Unseen Hand from our buff pile, then we should theoretically lose the ability to draw an extra card. So we're making sure that we're resetting our churns every single time and they're being recalculated. And any time that would have anything that's cumulative like that, I would go ahead and clean it up through my cleanup phase. Game over. This just happens whenever you fail to win the game, which is if any stat gets below 0, it initiates this function. It basically just says you lost the game, it waits 2 seconds, and then it restarts the game. And that's it for our game board. We're almost done. We're going to go quickly through the rest. We have our hand logic. Our hand is actually what's in our hand. Really, all we have here is just formatting. There's nothing else that's going on here. We have an array for the cards that are in our hand, and we're just saying, hey, format them. Make sure that they display correctly. And to show that, if we go ahead and play the game again, you see not all the cards are in an order. They're kind of like fanned out. As if you were playing a card game, you would have them like fanned out, and it would kind of be like rotated a little bit. And let's actually go into 3D here. I'm not playing this viewport. We're going to draw some cards in our hand. Ooh, Unseen Greed. That will be good to get more cards. We'll go ahead and cast it. And we'll end the turn, and we'll draw 2 cards. Now we're going to detach from our player here, and we're going to rotate around the world. And you can see these cards, they are 3-dimensional. And so they're rotated a little bit, they're stacked on top of each other, they're not clipping, they're just nicely resting on each other. And that's basically what our format hand, that's basically all our hand class does. I was actually thinking about reducing this, moving this object type to something that would be, because I'm not going to have instances of hand per player, so it would probably make more sense to have it in the deck or something like that. Okay, we are now going to go to our deck logic. So right now we have some debugging logic. We have some logic to spawn our hand right here. And then we also generate 60, didn't ignore this little comment here. We're, go ahead and we're saying, hey, we want to have 60 cards generated in our deck. I have them randomly selected from a database. So I have a database that every row is just a card type. It just outputs the index, or the data table is literally just an index, and the class type of the card. So I randomly generate a number between 0 and 5, or in range, not in between, in range of 0 to 5. Once I get that integer, I then pull that ID from the database, and then we spawn that card into our deck. We do that 60 times, and we have a deck of 60 cards. We just have some logic to go ahead here. You can see some stuff that we're doing. We're just formatting our deck and stuff like that. We then have logic to draw cards. Since there's multiple type of cards, some things need to happen differently on draw. Like sometimes it goes to our hand, sometimes it needs us to make a choice, sometimes it goes to the debuff pile or goes to the buff pile. And so basically what we do is we draw the card, we do the animation to display it, and then we go into our card type and we go ahead and we do display single card. And in this logic, we say, hey, is there a custom cast event, something like that? and we go ahead and perform that there. Get top deck location. This is needed so that card that we draw, it flies up. Well, the height of the top card of the deck is going to be different every single time. So we can't just pull from a static location. We need a dynamic location because the top card of our deck is constantly moving as we draw. So this is just to make sure that we have the top card deck location. Calc elevator height. There's a little elevator that lifts the cards up. It tries to keep them. It tries to keep at least 20 cards on top of like above the game board. But once it gets down to below 20, it stays still and it'll just keep going out until you can see the bottom. Sorry, I got a bunch of cat hair on my face and it's making my face really itchy. This is just some tick functions just to go ahead and adjust the elevator height, rotate gears, stuff like that. Because they need a standard rate. They need to make sure that we're not moving across a static time frame, but they have a static rate. And that's to make sure the gears look like they're actually mechanically rotating correctly. And we'll go ahead and play. And like you can see the gears right here, and this is the elevator that lifts them up. So every time we draw a card, we're also calling that logic to make sure we're keeping that elevator the correct height it needs to be. And that's pretty much it. We're at about 46 minutes, so we're pretty much at the end. We're going to do one quick thing real quick. We're just going to show you the card types that we have so far. We have 6 cards, but we only have about 5 types. We have our parent card that contains all the information that's going to be passed down to every single card ever. Every single card is going to need a back, so we need to make sure that we have a card back. Not all the cards need a card face because they might have their own card face. An example, binary card needs to be able to split out from the bottom. So we don't have a front face for all of our cards within our parent cards. We do have things like the name of the card, its flavor text, things like that. And we'll zoom in here. You can just kind of see it floating in here. We also have the point in which we start spawning our cost types because our cost types are created dynamically. All we have to do in here is just go and say, hey, add a new row to our cost type or cost array here, and it'll automatically generate at runtime. We have a standard card. A standard card is a card that just goes to your hand and then you can play it. It has a one-shot effect. So instants, sorceries, things like that from Magic the Gathering, similar to that. Subselect, this is our Pathfinder card. Basically, that is when we have a card that gives us a subselection. So we can subselect it from a list of cards, decline or approve it. So we'll go ahead and take this one, and it goes to our hand. Also, the cool thing about this is that Hungry Maws is a binary card, which we'll go ahead and we'll see if we can get a Hungry Maws here real quick. Hungry Maws is a binary card. It's one of the type of cards that split. And you can see that it doesn't have any cast cost. The reason why it doesn't have any cast cost is because normally it's a card that is played, it's forced to be played once you draw it. However, because we use Pathfinder and we brought it to our hand, we can now play it whenever we want. So if we don't have the 2 cards in our discard pile, we could wait until we have it. So that's showing a little bit of the kind of crazy stuff that I'm hoping to do here with the game through the digital format. That's another thing is that things like Magic the Gathering, you're really limited to the physical format. You can't say, randomly generate a goblin type card. So things like Hearthstone and Hex, they've done a lot of stuff with the digital format that I think Magic the Gathering is kind of falling behind on. And I'm going to make my game use a lot of that digital real estate. But you can see here, this card, it forces us to play it because we drew it. We drew it from the deck, so we have to do one of these. We can't discard because we only have 1 card in our discard pile, so we lose 10 stats. But that's a binary card. I think we have 2 more types left. We have buff and debuffs. And basically, the only thing that's unique here is that they have a function that's called buff effect and debuff effect. And that's what we run. Every time that we are doing our buff phase or we're doing our debuff phase, we're iterating through every card that's in that zone and we're saying run that function. And it runs it once and that's how we add it up. And that is where we're at currently. So currently we have 7 days of progress because today we just did some code cleanup. We really didn't add anything. So this is 7 days of progress. The game should be done. Well, I mean, looks like I'm going to finish the game rather quickly, but the goal is 2 months. There's a lot of visual stuff that needs to be added. We need to add view portraits for all the cards. We need to add fun cards. So there's a lot of stuff to do. So for next week, our goal is going to be to create about 60 cards. We're going to try to create about 60 cards that are they kind of work together. At least there's like a theme between those 60 cards. we want to be able to make something that is actually kind of RNG. We want to try to generate something that has a win condition about 40% of the time. So we want to be a little bit harsh there. We are going to be defining our stats because right now we only have one stat that has a name, and this is this third stat right here. It's called order. So we need to generate all the stats. We're going to create some assets that will hang on this cliff face to kind of define the stat so you can remember it. And we're going to color code them. So the rails will match the color. Their cost types here will match the color, things like that. So we'll know what's what. So there's going to be a lot of like theory crafting and a lot of creative stuff that's happening and not much programming wise for this next week because we got a lot of the programming down. But I'm sure there'll be one or two things. We'll probably create a new card type that requires a bit of structure around it. But that right there is pretty much where we stand. 7 days worth of progress. I will update you next week. Thanks for watching. If you want to watch more, it's Twitch, Tree Makes a Game. Also, check out other streamers. Watch if you're a fan of Reddit. This is going to be posted up on Game Dev. And check out the other people. There's other people who stream. There's other people making games. Support the indie community. Thank you for your time. Fantastic day.